Okay, so this is a review for a quiz on integration using partial fractions. Now, this is a little bit while ago, but we are catching up with the midterm that we had to miss, and so we have to do this at some point. And so I want to do a little review for this. So the quiz will be Tuesday, April 14th. It's quite a while from now because we have a spring break in between, and there's some. Look at the website for the exact calculation of. This is our next class, okay, Tuesday, April 14th. Okay, so this quiz, this topic is about partial fractions. And there are two types of partial fractions. I remind you, there's the partial fractions where you factor in linear factors, and then there's the one where you have quadratic irreducible factors. Now, it's best to, I'll do one example of each. Okay, and I'm going to focus on the things that the way I will ask you on the test. Okay, so let's start with the first one here. So here's the first example. So the question is calculate the integral of the following rational function. Okay. And so remember, step one was always checking whether the right degrees. So let me just write it up here. The bottom, so the denominator, has degree 3. Right? Because it's a quadratic times a linear. So that's the denominator, right? Has degree 2, which is bigger than the degree of the numerator, which is 2. So we are good. We don't need to do anything. That's the normal case. I don't think I'm gonna. Otherwise, you have to do long division, but forget about that now. Okay, step 2. Step 2, you have to factor. Okay, so be careful. So factor the denominator. It's always about the denominator. The numerator is not so important here. Well, of course, it's going to play a role, but so we have to factor x squared minus 6x plus 9 times x plus 1. Now, it is already factored somehow, but perhaps not fully. And so the question is, okay, when you have a quadratic like that, is this quadratic irreducible or not? Okay, and before I go on, let me remind you, so if you have a general term like quadratic ax squared plus bx plus c, then we have the so-called discriminant. That is in the quadratic formula, that is the expression underneath the radical. Sorry, the radical itself is not part of it. Sorry. So that is the underneath this radical that I drew, but it's not part of it. B squared minus 4ac. And then there are two possibilities. Either this is positive, and therefore we have solutions, real solutions. Of this quantity, the discriminant is negative. And then that means since it's underneath a radical sign, it would be the radical of a negative number. So this would be I'll repeat, real solutions. So here we have real solutions, no real solutions. And for us, so this we mean quadratic irreducible. And this means, therefore, this quadratic cannot be factored. That's the irreducible mean. Okay. And otherwise, if we are in this situation, it can be factored. And so which situation are we in? You can verify here that actually in the first case we have it can be factored. And if you, well, there are many ways of factoring, right? You find two you write as x plus, or let me not write the sign here because we don't know yet what it's going to be, x. And then you need two numbers here that multiply to 9 and add up to -6. Okay? Or you recognize perhaps right away that this actually is a double product formula. In either case, you find this factorization. And then, of course, we have x plus 1, so we keep that, x plus 1. Now, what is important is that we have a repetition here, so we should indicate this by x minus 3 square x plus 1. And so this, remember, we called the multiplicity. The multiplicity of this factor. And this is important for our step 3, namely, now we have to propose a partial fraction. So propose partial fraction. And the way that this works is the general theory says if you have factored it this way, then you know that the original fraction, let me copy the original fraction, x squared minus 9x plus 22 over x squared minus 6x plus 9 times x plus 1 can be written as, well, let's see. Let's start with the factor with multiplicity 1. There's no power here, so that is multiplicity 1. So that means just it goes in the denominator, and on top we get a letter. Let's call it a. But now we have a multiplicity 2. That means we're going to have this factor twice in the denominator. But of course it cannot be the same, because otherwise it makes no it would be twice writing the same thing. That's silly. So what we do is we first write the first power and then the second power. And if the multiplicity would be higher, we would go even one higher to power. Remember? And so then we get letters on top of it, B and C, new letters that we have to determine. And there is always a rule. Remember we said that the degree was 3 of the denominator. Well, we will have 3 letters, unknowns, that we have to solve for. Okay? Okay, so this is what happens when you have multiplicity. This is the case where you can factor. This is the case where we have this is not the case for quadratic reducible. That's the next example I will do. Okay, so now, step 4 now is to solve. Solve for A, B, and C. Okay, and that one is a couple of steps we do. The first thing is to, in the equation that we have, multiply everything with the common denominator. So here we multiply with x squared minus 6x plus 9 times x plus 1 on this side, and the same here. But here we use a factored form. It's of course easier now to factor, then we can cancel. So what we get is then, on the left hand side we get of course just the numerator, because the whole denominator is now cancelled, equals, and be careful, of course I should perhaps copy this, right? It's each term here has to be multiplied. Sorry, I should give myself a bit more. And then we don't go too quick on this step, because this is where people so often make mistakes. So what we see, if x plus 1 plus x plus 1 cancels, so we would have ax minus 3 squared left, plus b, what is left here? Well, one of the x minus 3 cancels, so we get x minus 3 x plus 1. And then finally here, both of these cancel, so plus c times x plus 1. Okay, that was the first thing to do. The second thing is plug in roots. Roots of what? Always about the denominator. We're always talking about this guy. And of course, how do you find the roots? Well, you put this equal to 0. And then by the zero product property, either this term is 0 or this term is 0. So the roots here, the roots are x is 3. That's for this term. And for this term, of course, the root is x minus 1. Okay, so plug in. What does it mean? Plug in where? In this equation. Okay, so plug in, we get 9 minus 27 plus 22, that's on the left. And now on the right, I plug in 3, but notice that by plugging in 3, if I plug in 3 here, this will be 0, and if I plug in 3, this will be 0. So there's only one term left, okay? Sorry. Okay, so that's right on the term that's left, c times 3 plus 1. 3 plus 1, which is 4, okay? So what is this? This is now 31 minus 27, that is 4. And this is 4c. So from that we see that c is 1. Okay. Okay. X is negative 1. We plug it in again in same thing here. We plug it in this equation. We get minus 1 squared, that is 1. Minus 9 times minus 1, that is plus 9. Plus 22 equals. What is now cancelling? Again, 2 of the terms cancel, right? The terms that have an x plus 1 in here, if I plug in negative 1, that will be 0. If I plug in negative 1, that will be 0. And that's why I don't factor out things, because then I see much better this kind of cancellation. Okay, so the only thing left is the first term, and therefore we have a times -1, -3 squared, right? This is in here that we plug this in. Okay, so that is 16a, and then this one would be 32. And there, from there we see that a is 32 over 16, which is 2. Okay, but what about b? We run out of roots, and the reason is that we have, normally this degree 3 should have 3 roots, but because we have this multiplicity, two of these roots coincide. And so we have only 2 roots, and therefore we can only determine 2 of these letters. So what we need to do is plug a test point. Test point. That can be any number you choose to, as long as you don't take the ones that we used. Because if you plug them in, of course you're going to get the same calculation, and therefore you're not going to get b. So what we plug in, obvious choice here, x is 0. Let me do it in green. What I mean to say is I chose this. Okay, it doesn't have to be 0. You can be anything you want here. Okay, so if I plug this in, again, plugging in meaning in this equation here, I get 22, right? The first two terms are 0, equals a minus 3 squared plus b minus 3 times 1. I'm plugging 0 everywhere here, right? And then here 0, that gives me plus c. But we know what c is, we know what a is, so we can replace a by 2. So this is 2 times 9 plus b we don't know. This is minus 3 times b. Perhaps I should not write a plus here then. And c was 1, plus 1. Okay, so that's 18 plus 1 is 19. So that's 19 minus 3b. Bring this to the other side. I get 3 equals minus 3b. And if I solve for that, b is -1. Okay, so I have everything. So let's now go back to our integral. So our integral here, okay, we have now written this whole thing in partial fraction. I'm going to erase this here that I can show it better here, what we have, right? So these calculations, you can always go back on the movie, right? There's nothing lost here. Okay, so we see that this is equal to, let's see, a, we're looking from here now, a was 2, so it is the integral of 2 divided by x plus 1. b was -1, I remember, yeah, b was -1, so plus -1 x minus 3, that is this one, and then plus x minus 3 squared here, and I think that was again, c was 1, right? Yeah, c was 1. Okay, of course the last step, that's step 5 if you want, is now actually doing the integration. In this case it's still rather easy. You'll see with the quadratic reducibles it gets a little bit trickier. So let's go quickly over this one. This is of course just a variable in the denominator to the power 1, that is ln x plus 1. I said I don't care about the absolute value signs. Same here, minus ln x minus 3, but be very, very careful. A common mistake is to say, oh, this is ln of x minus 3 squared. No, we are now dealing with a different power, not just 1, and therefore the power rule kicks in. And the power rule says, okay, what you do, you add 1 to the exponent, so that becomes now -1, and divide by the exponent. Remember this actually means x minus 3 to the power -2, right? So that's why I got this. Okay, and then of course plus c. That's it. You don't have to simplify. That's fine. Okay, that's the case where we have everything factors, where we have multiplicities, yeah, I'll erase it. Okay, so let's go now to the other possibility that you can get. So one of these you will get. Okay, 4x squared minus 5x plus 2 divided by x squared plus 4 times x minus 2 dx. Okay, so again, step 1 is okay, right? The degree at the bottom is 3, on top is 2, so nothing to be done here. Step 2, we have to factor x squared plus 4 times x minus 2. Okay, good. It's almost factored. What about this guy? But now if you try to find, if you try to do this factoring trick, you'll find there is nothing you can plug in here. So that is already an indication, because you need two numbers multiplying to 4, but adding up to 0. That's, if you think about it, it's not possible. Well, let's look at the quadratic formula, the discriminant. What is the discriminant of this x squared plus 4? Well, the discriminant in general is b squared minus 4ac. Okay, b is what here? Well, b is 0, right? There's nothing here. There's no term with an x in. So you get minus 4 times a, that's 1, and c is 4. So minus 16. That's negative, so that's a quadratic irreducible. And there are several ways of seeing this. I checked it by using the discriminant, but you can also immediately see this cannot be factored. If I try to solve x squared plus, it cannot be factored. And the same thing is, it doesn't have a solution. X squared plus 4 equals 0. That would mean x squared is negative 4, but no square can be negative. So that's another indication, quadratic irreducible. Okay. But it's important that we know this, that it's quadratic irreducible, because this is now in our next step. Okay? Because in our proposed fraction, 4x squared minus 5x plus 2 divided by x squared plus 4 times x minus 2. The proposed fraction now is, okay, x minus 2 is just what it is. It's a linear factor, so it goes on a letter on them. But here comes our quadratic irreducible. And now we do something else. We put bx plus c on top, which is different form than what we would have here. So please don't confuse here, right? You see here we have a, b, and c, but we have x minus 3 and x minus 3 squared. Here you have x squared plus 4 on it, so we cannot split it, so it has to be there in its entirety. And on top we have now a linear form. But notice again that the degree was 3. Well, we have 3 variables, so that's still the same. Step 4. We're going to solve for this. We have to first get rid of the denominator, so I'm just multiplying with the common denominator. X squared plus 4 times x minus 2, x squared plus 4 times x minus 2, x squared plus 4 times x minus 2. And well, I put already parentheses because I know that I have to multiply things, and if you multiply sums, you have to put parentheses around them. Okay, so what we get? So after this, of course, these denominators completely cancel, so we get 4x squared minus 5x plus 2 equals, here the x minus 2 cancels, so 8 times x squared plus 4, don't forget the parentheses. In quizzes and so on tests, you must make sure that you don't do these silly mistakes by not writing parentheses. Perhaps you know what you mean, but it is actually incorrect. If you would write this way, this would be ax squared plus 4, but that's not what we want. We want x squared plus 4. Okay. Now the x squared plus 4. Oops. No. I still have my eraser on. The x squared plus 4 cancels. Oh, why did I write it the third time here? That was silly. I didn't need this one, right? Okay. The x squared plus 4 cancels, so I get plus x minus 2 times bx plus c. Again, parentheses here because they're all sums. Remember, we don't expand. There is a method where you expand, but I don't explain the method. If you want to use that method, make sure you show all the steps and be very careful with it. Okay? Good. What we normally, now once we have cleared the denominators, now we plug in the roots, but that's the problem with quadratic irreducibles, right? They themselves don't have roots. Now we have another factor, so this actually produces a root, so x is 2 is a root. Okay, that comes from this factor equal to 0. Okay, alright, so x is 2, I plug that in. 4 times 2 squared, that's 16, minus 5 times 2, that's 10, plus 2 equals a. That's 4 plus 4, that is 8. 8 times 8. But if I plug in 2 here, again, because I haven't factored out, I see immediately that this factor will be 0, so the whole product will be 0. Okay. So I get plus 0 here. Let me write it just for emphasis. So we have now 6 plus 2. So 8 is 8a, and there a is 1. Well, that's good. We have a. But there are no roots anymore. So now we have to plug in test points, random numbers, whatever you call them. And of course, that should not be 2, because if I plug in 2, I'm going to get the same result. Okay, so I am going to plug in, the first, simplest of all is x equals 0. Okay, if I plug that in, I get on the left-hand side 2, right? These two guys disappear. And then on the right-hand side, I get 4a. And, oh, I should have not had this, the red here. Let me try, okay, got rid of it. I plug in 0 here and 0 there, so I get minus 2c. Right? Minus 2 times c. Okay. Right, and I know that a is 1. So a is 1, so that gets 4 minus 2c. Bring this to the side. Minus 2 equals minus 2c. I see that c is 1. I got lucky, I found c. Normally, and perhaps I should have done a problem where this happens, you will have an equation here. So I'll do a little problem quickly later on to show you that this is not always as easy as it looks. Okay, so, but I still don't have b. How do I get to b? Well, another point. So second test point, because I still need b. Again, I should take something I have not used, so x equals 1. But this is just an example, right? You can take anything you want here. So plug this in. Always in this equation, 4 minus 5 plus 2 equals a times 5, right? Plus 1 minus 2, that's negative 1. And then b plus c. Okay, I have, right, the left hand side is here, minus 1 plus 2, that's 1. A was 1, so that is 5. C is 1, so that is minus b minus c, but that's 1. Right, I distribute the negative sign and then we use that c is 1. Okay, and so bring everything to the other side. That is 2 minus 5 is b, so I see that b is negative 3. Okay, now I have everything. So I can do the integration. So let's go to the integration part now. So step 5. And I said this is a little bit more involved here, as you'll see. Okay, let me copy it again. So it is 4x squared minus 5x plus 2 over x squared plus 4 times x minus 2 dx. And that is the same as the integral. Well, what we have here, a was 1. Yeah, okay, so 1 over x minus 2 plus, and now this guy here, so that is in the denominator we have x squared plus 4, and on top we have bx minus 3x plus c plus 1. Okay. The first guy is again just power 1 in the denominator, so that the derivative will be an ln, so that is going to be ln of x minus 2. But what to do with this guy? Okay, so plus. Now, there are two things that we have to look at. First of all, I want the denominator should actually be in the special form x squared plus 1, because that is the antiderivative of the arctangent. Since I have the 4, I have to factor out the 4. So I'm going to do this, so what is left is this one, right? And I'll work it out a little bit here and then plug it in later. Okay, so minus 3x plus 4. And the first thing I said is I want this guy to be a 1 here. So I'm going to factor out a 4. 4x squared over 4 plus 1. If I factor out a 4 in a sum, I have to factor out in each term. So that's why I have a 4 here in the denominator. Okay, but I want this denominator to be a square, right? A square plus 1. So I have one more rewriting, 3x plus 4, and I write this as, there's a 4 here, x over 2 squared. I bring the 4 inside the square, plus 1. And now I'm where I want to be. You can work out straightforward, but I like to do an auxiliary substitution. So auxiliary substitution means it just helps me to make things easier. Namely, I do u is x over 2. I don't want to work with the fractions too much. So that means 2u is x, so that means 2 times du is dx. Okay, so I can plug in, I'm going to have to plug this in substitution here, right? So first of all, in this x, this becomes now 2u, so I get minus 3 times 2u plus 4. The dx is 2 times du, so times 2 times du, and in the denominator I get now 4u squared plus 1. Right? This thing becomes u squared. Okay, let's see what we have here. We have the 2 and the 4. I can factor that out. That's 2 over 4, and then minus 6u plus 4u squared plus 1 du. And now, when we have this denominator, we can split. So we split at this point, meaning, so we have the half here, and then I split it in two parts, the one with the u plus the one without u. Why do I do this? Well, first of all, this one is just now arctangent of u. We have a 4, so 4 times arctangent of u. What about this one? Since we have a u squared plus 1 here, we can use now substitution, because if we do w is u squared plus 1, there's another substitution, right? So I use it in a different letter. Always use different variables when you do substitution. Whatever the given variable is, choose something else. Okay, so w is u squared plus 1, so dw is 2u du. So let's solve for u du, so dw over 2 is u du. And now I can plug in, right? So let's see what we get here. This u du, that's this u du, right? Okay, so we're gonna get equal to a half. The whole thing is a half, so I shouldn't forget that. I get the minus 6, that's just constant. U du that we just said was dw over 2. And what do we have in the denominator? Well, u squared plus 1, that is just w. Okay, that's this. And then this, I'm going to distribute a half already, plus a half times this guy, 4 arctangent of u. Now, and now it's just a matter of plugging everything back in and then gathering all the factors. We have a 2, and a minus 6, so minus 6 over 4. Oh, there's still an integral here, sorry, I forgot my integral sign. And then this integral of 1 over w, that is just ln of w, okay? And then plus here, this simplifies to 2 times arctangent of u. And u was what? Let's go back. U was x over 2, so let's fill this already in here. So that is x over 2. And now let's fill in w. W was u squared plus 1, so I'm going to do this also here. U squared plus 1, and then u itself was x over 2. So I'll write this one more time. Minus 6, 4, minus 3 halves, of course, ln. U was x over 2 squared plus 1. This is the u replaced by x over 2, plus 2 times arctangent x over 2. Now remember, I was doing this separately, so the final answer is, I have this term here also. So the final answer, I'll squeeze it in here, would be ln x minus 2 minus 6/4 ln x squared, x over 2 squared plus 1, and then the last term was plus 2 times arctangent x over 2, plus 2 arctangent x over 2 plus c. Sorry, it got a little messy, but I think you can still read it, right? Okay. Okay, so that's the two different cases. As I said, sometimes you're going to have to find, it's not always, if you have to plug in the case of test points here, quadratic reducible, if you're lucky, you can plug in x equals 0, the b disappears because of it's b times 0 then. But in general, that's not possible. And then you have to solve a linear system of equations, okay? I haven't done an exercise like that, but there are homework problems, and we had done homework problems before, so look at that to see how this would work, okay? All right, so this is the quiz that will be on Tuesday after the spring break. And what I was going to say about this is, right, remember the quiz itself has to be done during the period given or during our class period.